Damn it. All right, so because we started with glucose, so we have 2 times through the Krebs step and 2 times around the Krebs cycle. So you can just cheat and look at this little table over here, right? So 2 ATP, we know that we make 6 NADH. We get rid of 4 carbon dioxide, and this is where we finally produce some FADH2. And there's 2 of them, again, because we're going around twice, because we're talking about the complete oxidation of glucose. Right. So to summarize, just ATP that we've produced, just pure ATP, just straight up ATP, we've already made 4. If we add up the NADH molecules we have, 2 plus 2 plus 6, that gives us a total of 10. I'm going to switch here. We have a total of 10 NADH and 6 carbon dioxides, which is great because glucose has 6 carbons and 6 oxygens, so we've released all of them. The NADH, these 10 NADH, all 10 of them, they go to the electron transport chain, which I'm just abbreviating like this, ETC, with these jumps to indicate the movement of the electrons. And you might remember from last week, and I know this isn't an area that's hard for you to see, so I'll put it over here. 1 NADH to the electron transport chain gives you 3 ATP. So it's 3 ATP per a single NADH. So if I have 10 of them, 10 times 3, that's going to give me 30 ATP. Passing the electrons, right? I need some shims in my life here. Hold it. So that gives you 30 ATP plus these 4, right? So we're up to 34 so far from 1 glucose. Now those last 4 come from our FADH2 friends. So they also go to the electron transport chain. We only have 2 of them. So I'm going to put them in a triangle because I had them in a triangle before. I'm trying to shim my chair here so that but I don't think that's the best I can do. So these 2 FADH2s also come to electron transport chain, but remember they come later than FADH or than NADH. So they have less potential energy, fewer electrons are passed, fewer protons are pumped through ATP synthase. So every FADH2, remember, only gives us 2 ATP. But we have 2 of them. So 2 times 2 is 4. So if I am a bacteria, I do actually produce 38 ATP from a single glucose. I've got 30 here from the 10 NADH, 4 that I collected up from glycolysis and the Krebs cycle directly, and then 4 more from the FADH2. So I can see a grand total of 38 ATP. So hopefully that'll help a little bit with sort of summarizing and keeping it straight about all the ATP and how it's produced. I'll just let it sit there for a second so you can take a look at it and screenshot it if you want or whatever. Come back over here. All right, so anybody have any other questions? Did that trigger any other questions that you want to ask about cellular respiration or fermentation or anaerobic respiration before I stop this recording and move on to chapter 9? Yes, no? All right, so I'm going to hit stop.